So it is logarithmic functions. See, this topic is not in the syllabus of school syllabus, but this keep on coming every day again and again in our usual topics. All right. So also 12th May, it's a very prominent topic. JEE May, it's a prominent topic. So since it is quite an important topic, so we will do it. First of all, understand log is an operator. Log is an operator. Like every number, say there's a number n. Let me take 49. There are two ways to write it. One is exponential way and other is logarithmic way. Now exponential way is what? Like 7 square is 49. So what is exponential way? Like 7 square is 49. All right. So here this 7 is called base. This 7 is what we call base. This 2 is what we call power or index. Got it? Now, in a logarithmic way, how do we write it? Log 49 base 7. So take it like, what should be the power of 7 to make it 49? Answer will be 2. Got it? What should be the power of 7 to make it 49? Am I clear? And that is why the answer is 2. Here this 7 is what we call base of the log. This 49 is, which is a number that is a component of the log. And this 2 is what? This is the number we are talking about. And or index. So now if I ask you log 81 base 3. So take it like, what should be the power of 3 to make it 81? Tell me, you may use the chat box. What should be the power of 3 to make it 81? This answer will be 4. Log 125 base under root 5. Very good, Roshan. What should be the power of under root 5 to make it 125? So answer will be what? 6. 5 cube is 125. So root 5 to the power 6 will be 125. Am I correct? Now if I ask you log 81 base 27 is what? What should be the power of 27 so that it becomes 81? So let us assume 27 to the power k is 81. So k is your answer. So 27 ko you can write 3 to the power 3k. 81 is what? 3 to the power 4. Means 3k is 4. So k is what? 4 by 3. So that means this power is what? 4 by 3. So if 27 raised to the power 4 by 3, you will get 81. Am I correct? Log 1000 base 10. What should be the power of 10 to make it 1000? Yes, please, answer is. What should be the power of 10 to make it 1000? Answer will be 3. Now if I ask you log 1 by n base n. What should be the power of n to make it 1 by n? Answer will be -1. Am I clear? So these are the things that you need to take care. So now what did we get from here? Log x base a, if you get it n, that means what? This x has been obtained by doing a raised to the power n. If log x base a is n, that means x is what? X is a raised to the power n. Am I correct? Simply x is what? A raised to the power n. Now see, log 1 to any base b will always be 0. B to the power what is 1? 0. Got it? So this log x base a, it is defined if x is greater than 0, first of all, पहली दिन. Second, a should be more than 0 and a should not be 1. You just remember it. This log x base a is defined only if x is more than 0, a is more than 0, and a is not equal to 1. Am I correct? Now see a few very common things. One thing I told you, log 1 to any base b is what? 0. B should not be 1. B cannot be 1. Now log n to base 1 by n. If component and base, they are reciprocal of each other, value will be -1. And log n base n, if component and base both are same, then value will be 1. Am I correct? Take a look quickly. Now, I'll ask you a few very simple questions. Log cos 60 base sin 30. First. Second, log 1.3 bar base 4 by 3. Third, log 2 plus root 3 base 2 minus root 3. This is what? Try all of them quickly. First answer is 1. Very good. Roshan, very good, beta. This will be what? This will be log 60 is what? 1 by 2. Sin 30 is 1 by 2. So 1 by 2 to the power what? We get 1 by 2. Answer will be 1. How about the second one? Now, if you remember, this 1.3 bar is also 4 by 3. Got it? So this goes what? Log 4 by 3 base 4 by 3. Answer is 1. Answer to the third one. Now, see, this 2 plus root 3 into 2 minus root 3 is what? 4 minus 3, it is 1. That means this 2 plus root 3 and 2 minus root 3, they are reciprocals of each other. Yes or no? कोई बात नहीं. 2 3. And if they are reciprocal of each other, this answer will be what? -1. Got it? So these were small things about log. Now, let's go with principal properties of log. Principal properties of log. Now see the first one. Log m base a plus log n base a is equals to log mn base a. One thing to take care, what generally students do, log m base a plus log n base a. Now what do? They take log common. So it is m plus n base a. This is what we are not going to do. Log is an operator, it won't come common, like sine cannot come common. Sin x can, but sine cannot be. Similarly, you cannot take log common. So log m base a plus log n base a is log mn base a. Second property, log m base a minus log n base a. Log m upon n base a. And third, log m to the power n base a is n log m base. This power will come out common. Got it? This power will come common. So these are the three basic properties of log. Now there's a fourth one, a to the power log m base a. If it is like this, these both a will cancel out, you get answer as n. Very, very important. Yeah, this is very useful in 12th class. A to the power log m base a is n. Got it? Just give me a moment, you copy these things. आप कर लो। दूसरी क्लास ले लो। All right. So I think you have noted it down. Now, the next property is uh, log m base n. See, this is what we call base changing theorem. Base changing theorem. So log m base n. This is what? Log m base a upon log n base a. You know, the exact theorem is the quotient of the logarithm of two numbers is independent of their common base. This base should be same in both numerator and denominator. Got it? So quotient of log of two numbers is independent of their common base. Quotient of the logarithm of two numbers is independent of their common base. And because of this, we can see log m to the power, say you have x, n to the power y. So the power of the component will come out in the numerator using property 3, and power of y, power of n, will come into the denominator using base changing theorem. So it will be x upon y log m base n. X upon y log m base n. Now, from the base changing theorem, we can also say that log a base b into log b base a, this is 1. Means log a base b and log b base a, they are reciprocals of each other. How come? Say this log a base b into log b base a. You break this log a base b at some common base, say t. So log a base t upon log b base t using base changing theorem. Now also break this log b base a at the same common base. So log b base t upon log a base t. So log a cancel, log b cancel, your answer goes 1. So this is what we call base changing theorem. Am I correct? Base changing theorem. Got it? Now see, now we'll do some mixed questions for all the properties. Find the value of 2 to the power minus log 7 base 1 by 2 plus 81 to the power minus 1
sir.
upon log 2 base 3 plus 3 to the power log 3 base 3 to the power log 5 base under root 3. Give it a try. Find the value of this. Yes, anybody?
Good afternoon, sir.
Sorry? Now see. First one. What is its value? It can be written as 2 to the power minus 1 whole to the power log 7 base 1 by 2. To which I can write 1 by 2 to the power log 7 base 1 by 2. Now use this property. A to the power log m base a is equals to m. So base of log upon base of exponent, they both are same. Yes or no? So here also 1 by 2 is same. So answer of this part will be 7. Correct? Now let's go with this one. This is what? This is 2 cube whole to the power. Now if I take this minus outside and I write it log 3 base 2. Reciprocal of log 2 base 3 is log 3 base 2. So this can be written as 2 to the power minus 3 log 3 base 2. This minus 3 goes to the power of 3. So 2 to the power log 1 upon 27 base 2. Answer will be 1 by 27. Correct? Now come to this one. This can be written as under root 3 square log 5 base under root 3. Now again this power goes to the power of 5. We can write it log 3 to the power log 25 base root 3. Answer is 25. Correct? So what will be my final answer? Final answer will be 7 plus 1 by 27 plus 25. So it is 32 plus 1 by 27. I hope now you can do it. Clear? Now see a next question. Okay, properties में ही one more property. A to the power log b base c. A raised to the power log b base c. So here you can interchange this a and b. C will remain as it is, no change in c. So it will become b to the power log a base c. Very useful. A to the power log b base c is b to the power log a base c. Proof is also very simple, but let's not dig into the proof right now. So this is it. Now write any question on it. Let a more than 1. Find the real number. Find the real number x such that a to the power 2 log x base 2 is equals to 5 plus 4 times x to the power log a base 2. Give it a try. Quickly try. See, this first term can be written as a to the power or even a to the power log x base 2 whole square minus 4 times. This x to the power log a base 2 can also be written as, let's keep it as it is. X to the power log a base 2 minus 5 equals to 0. Now this particular term, here a and x can be interchanged just by using the property I told you before. So x to the power log a base 2 whole square. 4 times x to the power log a base 2. Now let us assume this x to the power log a base 2 is t. So t square minus 4t minus 5 equals to 0. So it is t minus 5, t plus 1 equals to 0. Am I correct? So t came minus 1 and 5. T came minus 1 and 5. Means x to the power log a base 2 is minus 1 and 5. Now this cannot be minus 1. Exponential function it is. So power function, so it cannot be minus 1. So that means x to the power log a base 2 is 5. So x will be what? 5 to the power log 2 base a. That is reciprocal of log a base 5. Got it? Now, next question. Find the value of x satisfying x square plus 7 to the power log x base 7 minus 2 equal to 0. Give it a try quickly. Now, see, first of all, one thing to analyze, what is this? 7 to the power log x base 7, this value will be x, isn't it? So it became x square plus x minus 2 equal to 0. If you factorize it, you get x plus 2 into x minus 1 equals to 0. So value of x is minus 2 comma 1. Now see, since x is the component of log x has to be more than 0. Yes or no? So that means x equals to 1, x equals to minus 2 reject. Am I correct? Now, let's take another question. X plus 1 to the power log x plus 1 base 100 times x plus 1. X plus 1 to the power log x plus 1 base 10 is 100 times x plus 1. So first of all, take log both sides. Like in this kind of question, there is a variable in the power, variable in the component. So you first of all take log both sides. So that means log x plus 1 to the power log x plus 1 base 10 is log 100 times x plus 1 base 10. Correct? Now if you see, this power of component will come out. So this will become log x plus 1 base 10 whole square. is equals to log 100 base 10 plus log x plus 1 base 10. Now again same thing. Let us assume log x plus 1 base 10 is t. So it is t square minus t minus 2 equal to 0. Log 100 base 10 is 2. So it will become t minus 2 into t plus 1 equals to 0. So t की values है minus 1 comma 2. That means log x plus 1 base 10 is minus 1 comma 2. So x plus 1 is what? 10 to the power minus 1 is 1 by 10 and 10 to the power 2 is 100. So value of x is 99 or minus of 0.9. These are your two answers. Check it once. Got it? Now, next question is mod of x minus 3 this is 1. Mod of x minus 3 raised to the power 3x square minus 10x plus 3 is equals to 1. Now see, as an obvious case, if I see the possibilities are either base of the exponent goes 1 or this power goes 0. Now if I want to see it mathematically, how do we do it? We take log to the both sides. Mod x minus 3 is 3x square minus 10x plus 3 is log 1. Log 1 is 0 and this power will come outside. So 3x square minus 10x plus 3 log of the mod x plus 3 is this is 0. Now either this is 0, that means 3x square minus 10x plus 3 equals to 0. Its factors will be 3x minus 1 into x minus 3 equals to 0. So values of x are 1 by 3 and 3. Or this log of mod x minus 3 is 0. Means mod x minus 3 is 1. So x minus 3 is plus minus 1. So x is 2 or 4. याद है याद है याद है पापा को याद है got it? So answer is 1 by 3, 3, 2 and 4. Got it? So this is all about the properties of log and just go through them once again and again and again. This is important. And now just